Hello everyone, welcome back to ZC Classes English YouTube channel. So dear students, as you all know, we are having the series called Pharma 360 Degree, and today again we are having a session on organic chemistry, and we are going to see 20 questions from organic chemistry from the topic elimination reactions. So let's have what we know about the elimination reaction. We are starting with the question. So first question we are having: which of the following best describes an elimination reaction? So as we all know, in the organic reactions, majority of the compounds, majority of the type of reactions are basically having in either they are addition kind of reaction, they are actually having elimination kind of reactions, or substitution kind of reactions. So when we are talking about the elimination, as the name suggests, like they are always having some of the groups that are actually going away from a substrate molecule, and we are having a pi bond formation in the product side. So that means the product will be less stabilized since we are having a pi bond there, and in the substrates we are not having that pi bond earlier. So addition of atoms or groups two adjacent carbon atoms, not at all. So this is not about the addition. If you are having addition on a substrate, then must be having addition kind of reaction. So this is not the right answer. Loss of atoms or groups from adjacent carbon atoms forming a pi bond. Yes, very well. Like yes, we are having a pi bond formation. Suppose we are having CH3 CH2 Cl, and we are having KOH alcoholic. It means like this reagent will be doing elimination. This will be eliminating Cl and proton from this carbon, leading to the formation of ethene, that is CH2 double bond CH2, and it's an elimination kind of reaction where one of the chlorine from this carbon and hydrogen or proton from this carbon is removed, and thus we are having an elimination product with the formation of a pi bond. So two sigma bonds break down to form a pi bond. So yes, this is the correct definition for an elimination reaction. Exchange means it must be having substitution, so not at all, this is not possible. Formation of a single bond from double, no, this is also addition kind of reaction, so this is not correct way. So right answer will be B. Yes, B is the right answer. Here you can see, in an elimination reaction, atom or groups are removed from the two adjacent carbons, so it is also known as alpha beta kind of elimination. Look, elimination is basically three types, like it is alpha alpha elimination, alpha beta elimination, and alpha gamma elimination. They are having three kind of elimination reactions, but the majority of the elimination reactions are following alpha beta kind of elimination, where the removal of the groups is taking place from adjacent carbon atoms. Okay, so that's why we are basically focusing on the alpha beta kind of eliminations, resulting in the formation of a double bond, that is a pi bond between those two carbon atoms that are adjacent to each other. So substitution, in the substitution, one of the group substitutes the already present groups in the substrate, and that is known as substitution. In the addition, we are having two different compounds and they are adding up to give a single separate product, that is a addition kind of reaction. In the elimination, we are having removal of something, so you can also say that it's a complete reversal reaction of the addition reaction. Elimination reactions, next question we are having, are generally considered the reversal of which type of reaction? So addition reactions. Okay, simple. In the addition, we are having addition of some substrate, some of the groups. It means they are having addition, while in the elimination we are having elimination of the groups, eliminating the species. So this will be a reverse of, not substitution, not oxidation. Yes, that will addition. Addition is the reverse of elimination, or you can say elimination is the reverse of addition reaction. So C will be your right answer for this question. Okay, C will be the right answer. Which of the following is not a characteristic of elimination reaction? So which is a not characteristic of a elimination kind of reaction? Formation of a pi bond, yes, that is a must condition. So yes, this is true. Involves adjacent carbon atom. It is in general present on the adjacent carbon atoms. Yes, so yes, that is also correct. Loss of atoms or groups from a single carbon atom. This is alpha alpha elimination, but that is not right now we are having that much significance in this statement, in this question. So we'll be not correcting this, but looking the next option, we are having opposite to the addition reaction, so that is also 100% correct. So this is also right. So this is your most appropriate answer, means that is wrongly written here. So you are being asked which is not a characteristic feature. So elimination is a alpha beta most of the time elimination reaction, so that is the right answer for you. It means this is not the right answer written here. Right, the C is the correct answer. C will be your right answer. What type of bond is typically formed between the two carbon atoms after an elimination reaction? So after an elimination reaction, we knew like two sigma bonds broken down to form a pi bond. It means, is it ionic bond? No, no ionic bond formation, no sigma bond formation. Instead, two of the sigma bonds broken down, two sigma bonds broken to form a one pi bond, single pi bond. Single pi bond, one pi bond. So yes, this is the formation, this is the breaking covalent bond. Yes, that is a covalent bond, but the most appropriate answer will be a pi bond. Always a pi bond formation is seen. Okay, pi bond formation. Elimination reactions are divided into which of the following classes? Elimination reactions are divided into which classes? E1 and E2. Yes, very well. SN1, SN2, these are substitution reactions. Okay, so they are the characteristic substitution reactions, SN1, SN2. Oxidation reduction, no, this is not the correct. Electrophilic and nucleophilic, no, this is not correct. So just A, that is E1 and E2, elimination unimolecular and elimination bimolecular, and one more, that is E1CB, elimination unimolecular conjugate base mechanism. So that is also a kind of elimination reaction. So A is your right answer here. A will be the right option. Okay, so organic reactions are divided into substitution, addition, elimination, and rearrangements. Addition are having free radical, nucleophilic and nucleophilic additions. Additions and substitutions will be also having same free radical, nucleophilic, electrophilic substitutions. Elimination are having E1, E2 and E1CB. What is the first step in an even elimination reaction? So even reactions are having two step mechanisms. In the first step, we are having leaving group. We are having removal of the leaving group. So leaving group leaves the substrate, leading to the formation of a carbocation intermediate. And in the second step, we are seeing like a base approaches and abstracts a proton from the substrate, leaving a pi bond there. So in the first step, we are having loss of proton to form double bond. No, this is second step. That's in the second step. It's a second step. But in the first step, we are having loss of leaving group to form a carbocation. Yes, that is correct. That is correct. Simultaneous removal of H and leaving group, this is for E2 mechanism. We are being asked about the E1. So this is about the E2 mechanism. Okay. Attack by a nucleophile. No, not at all. So all these are wrong. B will be the right answer. B will be the right answer. In the even reaction, we are having first step, the leaving group leaves the compound. Okay, leaving group, look, we are having substrate, leaving group leaves leading to the formation of a carbocation. In the second step, a base approaches and abstracts a proton for the formation of a pi bond. So in this two step, this even reaction gets completed, and this is the mechanism. What distinguishes even elimination from SN1 substitution? So even, that is an elimination reaction, SN1, that is a substitution reaction. Both are two-step mechanisms. This is having in the first step we are having removal of the leaving group in the both the cases. In the second step we are having removal of the proton in E1, while attack of a new nucleophile to your substrate on the carbocation side. Formation of a carbocation intermediate. So this is same. That is same for both. Occurrence in protic solvents. Yes, they are actually happening in the polar protic solvents. So yes, that is also correct. Loss of proton in E1 but substitution in SN1. Yes, that is correct. That is correct. That is actually distinguishing. Okay, in the E1 we are having loss of proton, while in the SN1 we are having substitution. So that is correct. Simultaneous dissociation of the leaving group and proton. No, this is not about the E1 and SN1. So this C is your rightly distinguishing the SN1 and E1. So yes, C will be your correct option for this question. C will be the correct option for this question. So C is right. Which type of solvent is most favorable for E1 reaction? So just right now I told you, for E1 and SN1 we are having polar and protic solvents. Polar and protic solvents, the solvents that are having polarity and those which can produce protons. So they are polar and protic solvents. Polar and protic solvents like alcohol. Alcohols are having polarity and protic solvents. H2O is again a polar and protic solvent. Next we are talking about acids. They are having polarity and they are protic solvents. They are polar protic solvents. So polar and protic solvents, protic polar solvents. Yes, C is the right answer. C will be the right answer. Okay, polar and protic solvents like water, alcohol, methanol, ethanol. Okay. Next question we are having, which product is favored in elimination reaction when a bulky base is used? So during the elimination reaction, we knew like one of the base approaches to a substrate and gives you a product. Now we are having two kind of elimination, two kind of products formation when we are having a unsymmetrical alkene. Like suppose we are having CH3C and we are having CH3 CH Cl CH2 and CH3. So this is we are having this is the alkyl net that we are having now. So if we are using a bulky base, after the removal of the leaving group, we are having this CH carbocation followed by CH2 and CH3. This is what we are having. So if the base is small, that is not that much big, so that leads to the formation of a Sadjeff product. Sadjeff elimination rule we are applied here, and we are going to get the product that is following the Sadjeff rule, or also known as Jatsev rule. Jatsev rule says like you can only, we are having now proton removal possible from here as well as here. So Jatsev told like we remove the proton from that carbon, that leads to give you a better substituted alkene. So suppose we remove this proton from this CH2 carbon, that will be giving you CH3 CH double bond CH and CH3. This is your Jatsev product. This is only possible when we are using the smaller bases that are not so much bulky. But suppose we are using tertiary butoxide ion, CH3 CH3 CH3. It's a bulky base. It's a bulky base. Now this bulky base cannot ever approach us to this carbon. We are not having the possibility to approach this carbon for this base. So that's why this base approaches to this CH3 and removes one of the proton from here and gives you a product, that is CH2 double bond CH CH2 CH3. This product, and this is known as Hoffman product. And this is known as Hoffman product. This is known as Sadjeff or sometimes known as Jatsev product. Jatsev product. Okay. So for when the base is bulky, we will be getting the Hoffman product, and when the base is small, short, then we will be getting Jatsev or Sadjeff product as the major one. So bulky base will be giving you the Hoffman product. Hoffman product. Okay. Hoffman product. Moving to the next question. The rate law for E2 reaction is proportional to. So for the E1, we are having even rate of reaction is directly proportional to the quantity of your substrate. You can write down just substrate. The rate of reaction for the E1 depends only and only on the substrate, while the rate of reaction for E2 depends on the substrate concentration as well as base concentration, since it's a one step reaction. This proceeds in one step, that's why the rate of reaction depends on both the concentration of substrate as well as base, while for the E1 the concentration of substrate only describes the rate of reaction. So for the E2 we are having Rx only, no, not at all, means substrate. Okay, base only, no, substrate and base, yes, that is correct. So for the E2 this, and for the E1 just substrate. Okay, so this is for the E1 and this is for the E2. Moving to the next question. Which type of alcohol typically undergoes an elimination reaction via the E2 mechanism? Now, we are being asked which of the following alcohol can be undergoing elimination via E2? Primary alcohol, secondary, tertiary, or allylic? We know very well the elimination reactions must be having less steric hindrance, so that your base approaches to the substrate molecule and removes the proton. So that's why for the case of E2 we will be looking for the less substituted alcohol, that is a primary alcohol. For the E2 we will be having a less substituted alcohol. For the E1 we must be looking for a better substituted alcohol, means better stable carbocation we must be getting. So that's why primary alcohol will be correct for the E2, while for the E1 we will be having the tertiary alcohol or allylic, since we are also having the resonance stability on the allylic. What is the preferred product in E2 reaction with a strong base and a primary alcohol? So we are having a strong base and a primary alcohol, and we are having a E2 mechanism. It means we are having a strong base, primary alcohol, E2 reaction. E2 reaction we must be having Sadjeff product. Sadjeff product, that is also known as 𝙤𝙬 product. 𝙤𝙬 product. Since there is no any discussion about the bulky base, so we must be using 𝙤𝙬 product or also known as SERES product. Suppose we are having a bulky base, it's written like we are having a bulky base, then we will be putting Hofmann product as a right answer. 2-bromopentane is heated with potassium ethoxide, so it's a base potassium ethoxide. Potassium ethoxide. We are having C2H5O minus K plus. This is potassium ethoxide. We are having 2-bromopentane. 2-bromo Br 2-bromopentane. So this is what we are having. 1, 2, 3, 4, 5. 2-bromopentane. It's a base. That's a substrate molecule. This reaction must be proceeding with the even mechanism. High even mechanism. Since this carbon is a 2-degree carbon, so that's why we must be having a E2 better possible chances to be taking place here. And now the removal of bromine will be giving you a here, and the proton will be removed either from this side, from both the sides. Now we must be having the better chances for the removal of proton from this carbon. Why? It will be giving you a better substituted alkene, more stable alkene, that is a SERES product. That means we are having CH3, CH double bond, CH single bond, CH2, CH3. So this is what? 2-pentene. So we are having pent-1-ene, not at all, trans-pentoene, 2-ethoxypentene, it's cis-pentoene. Now, what will be the correct answer now? Which will be the right answer? We are having a trans and we are having a cis-pentoene. Always remember, the stability of alkene is better or more for trans form than its cis form. Trans form of alkene is more stabilized than the cis form. That's why we are going to write down the answer like this will be the better stable, that is trans-butene. That will be trans-butene. So A will be the right answer. A will be the right answer here. Which of the following correctly describes the kinetics of the E2 reaction? Kinetics of the E2 reaction. First order, as the name suggests, E2, it means it's a second order. For E1, that will be first order. For SN1, it will be a first order. SN2 will be a second order. E2 will be second order. Okay, so E2 will be the second order reaction. Kinetics. For the E1, it's a first order. E2 second order. E1 is a unimolecular, bimolecular, needs a weak bases. E2 needs strong bases. No special geometry. They are anti-periplanar. Rate is dependent only and only on the substrate concentration, while for the E2 we are having substrate as well as the base concentration. Substrate must be having 3:1. E2 must be having 3:1, but depending on the cases. Rearrangement possible since the formation of a cation, that is not possible since there is no any carbocation intermediate formation. What is these stereochemical requirements for the E2 reaction? No special geometry is required. This is for the case in E1. Just we have seen right now. Anti-periplanar arrangement of beta hydrogen and the leaving group. Yes, that is correct. Syn-periplanar, the reaction occurs without stereochemical constant. So A, C, D are wrong. Anti-periplanar. What does this anti-periplanarity means? Suppose we are having CCl hydrogen and we are having this adjacent carbon with something that is having CH3 group. Look now, suppose we are having this is our leaving group. Okay, I am writing down Lg for the leaving group. So this is the leaving group. Now we are having in the adjacent carbon we are having two hydrogens. One is Ha, one is Hb. Now which hydrogen to be removed now? So the hydrogen that is at 180 degree, or you can say that is in plane of the leaving group but opposite. We are having chlorine in the downside. One of the hydrogen must be having in the same plane, that is this one, and that is anti to the leaving group. So this Ha will be removed from here. This Ha will be removed from here. This is anti-periplanarity. Anti-periplanar. This is syn-periplanar. So This is anti-periplenarity. That is only possible requirement for a E2 reaction mechanism. So B is the right answer. B will be the right answer. So for the E2, elimination must be anti-periplanar arrangement of the various groups. Which reaction mechanism not allows rearrangement of the substrate? So for the rearrangement of the substrate, it must be happening only when the carbocation intermediate formation takes place. In the E1 we are having carbocation intermediate. In the E2 we do not have any carbocation formation. Both not right answer, neither not right answer. So only and only E2 can be the right answer. In the E2 we cannot see the rearrangement. Here for the both, E1 will be showing, E2 is not showing, so this is not the correct answer. Neither cannot be the correct since E1 is showing, E2 is not showing. So only the right answer is, that is E2. E2 will not be having any possible chances for the rearrangement of the cations. Which substrate is least reactive in even reaction? In an even reaction, which substrate is least reactive? Tertiary alkyl halide, secondary alkyl halide, primary alkyl halide, or allylic halide? So for the even, we are having the better substituted alkyl halide. That is a 3-degree alkyl halide, that is tertiary alkyl halide. So for the even, this will be having the highest reactivity. This will be having the highest reactivity. What the question is asking with us? The question is asking least reactive. That means the primary alkyl halide. This will be having the least reactivity. So least reactivity, yes, C is the right answer. C will be the right answer. Okay, so even least, but E2 will be happening on the primary alkyl halide as well as, okay, primary alkyl halide. What is the base strength requirement for an E2 reaction compared to an E1 reaction? So for the E2 we must be having a better base, and for E1 we must be having not that good base. Strong weak base can also proceed this kind of reaction of the E1. So both require weak bases? No, E1 requires weak base and E2 will be requiring a strong base. So E1 requires a strong? Not at all. E1 requires weak base, E2 requires a strong base. C is the right answer. C is the right answer. E1 weak, E2 strong. Why? Since the reactivity order, the rate of reaction for the E1 was independent of the concentration of base, while for the E2 we must be having the base strength concentration mattering. What is the nature of the transition state in an E2 reaction? So the nature of transition state, formation of a carbanion in the no, there is no any intermediate formation. Loss of leaving group and abstraction of beta hydrogen occurs simultaneously. Yes, that is the transition state. In the transition state, we are seeing that the leaving group is also being removed from the substrate, and the proton, the beta hydrogen, the beta proton is also getting removed. So it is happening in the single step. So yes, that is the right answer. That is also known as concerted mechanism. That is also known as a concerted mechanism. That is the removal of leaving group and the proton is taking place on the same step, in the same single step. That is also known as concerted mechanisms. Formation of carbocation intermediate, no. Involves free radicals, no, not at all. So B is the right answer. B will be the correct answer. B will be the right answer here. That is also known as concerted mechanism. Which reaction is an example of the E2 mechanism? Dehydration of E2, dehydration of 2-degree and 3-degree alcohols, dehydrogenation of alkyl halides, with alcoholic 𝘂𝐻, hydrolysis of alkyl halide, and SN2 substitution reactions. Now, we are being asked the example for E2 mechanism. So dehydration of 2-degree and 3-degree alcohol, yes, they are having E2 mechanisms, but E1 is also possible. Dehydrohalogenation of alkyl halide with alcoholic alkali. Now we are having alcoholic alkali, means stronger bases, and dehydrohalogenation, that is also a removal of hydrogens and halogens. So yes, that is an elimination kind of reaction. Hydrolysis of alkyl halide, not at all. SN2, not at all. So the most appropriate answer will be the B, that is dehydrohalogenation of alkyl halides in the presence of stronger bases, that is alcoholic alkalis. This is even mechanism. This 2-degree and 3-degree alcohols can be dehydrated by even mechanism as well. So the right answer will be B. B is the correct answer. So this is all about the elimination reactions. I hope you all have enjoyed this session, and I have explained each and every question with detail, so I hope you all listen very carefully. If you are getting any doubts, you can put it on the comment section. Thank you so much. We'll be meeting again with some new questions from the newer topics. Thank you all.